Okay. Let me screen share the assignment that I have to do today. I remember doing this stuff back in algebra, so I mean,
We just have to just set them equal to each other, right?
Yeah, the idea is that you try to find the x and y that make the system true. These three, and then the last one's to discuss and then finish the problem.
Oh, okay, so the last one looks long, but it's not.
It's not. It's just discuss and show. Just show and tell. So I guess, where were you all for Thanksgiving? Did you just chill around, or did you go someplace?
I was in Alaska.
I went down to Arizona.
Nice.
So that's always a good day.
I was in Seattle.
Dude, I was in Seattle for like 4 hours.
On Thanksgiving?
Not Thanksgiving Day, but on Saturday and on another Saturday.
Man, you should have come up.
Yeah. All right, how do we do this first one?
So are we just basically substituting things in for x that equal each other? So y.
There's a way to do it. There's a way to do it. I just can't quite remember. I'm trying to remember. You could do it like an addition, like you did simple addition, but I can't remember.
I thought you set them equal to each other.
Maybe. It's possible.
But I mean, the absolute value doesn't really make much of a difference because in the second part of the problem, it's a squared anyways, so we know that both of them have to be positive.
Mm-hmm. Gosh dang.
Like 3 - 2 absolute value is going to be 6, and like -2 squared is going to be +4, so.
Right. What was it? Darn, I can't remember how to. There's a simpler way to do it, but I can't remember.
Oh, you can also graph them and find where they intersect.
The problem, though, that is, as we all know and dread, there's no graphic calculator on the test. But that is a legitimate way to do it for homework.
That's dumb.
There's a way to do this, but what is that way to do it?
Well, let's see here. I'm pretty sure you just substitute things in for it and find out which numbers equal each other.
That is one way to do it. Oh, for goodness sake, though, there's a better way to do it. I can't remember the way, though. Well, let's see what, because she explains the last one, so let's see what she says in the last one. The following problem is a bit more difficult because it involves fractions with a variable in the denominator. The problem has been started. We discuss the method used and why it's good for, but method used to finish the problem. Multiplying the equation by -2.
Why did she multiply by -2?
Adding the equations together because they have a common denominator. What the? They don't have a common denominator? That makes no sense either. Oh, man, some days, for real.
Solving the following three systems as a team. Be sure to discuss the method being used. Working done. For the one intersection point, please remember that when solving systems of nonlinear equations, there can be more than one intersection point. Yeah, so I'm pretty sure all we need to do for this is we just got to solve it.
Yeah, but there's a way to do it.
So what I would do is, because if you put in a number for x, that's going to be your x value. And so all you need to do is you just got to plot down the points. So it really was what I was talking about. And so graphing, say, y equals 3x, you could put in 0 for it. And then so your x would be 0, your y would be 0. And then you could do, I think I read in the homework that if you do 2s, it'll avoid like things of 2s, so like 2, 4, 6, 8, 10, you know, type of a thing. You'll avoid fractions. And so then if you put in 2 for your next one, then it'd be 2 is your x value and y would be 6. And so if you just keep writing them down like that, then you'll be able to find all your points. Does that make sense? I did a couple problems in this, and that's how they told me to solve it. I did a couple problems in the math homework.
Yeah, sure.
I mean, 2 is the answer for the first one.
What?
2 is the answer to the first one.
Well, there can be multiple is the problem. And so in a sense, you do need to graph these almost because you got to see where they intersect, because you could have multiple points.
Well, shoot. Let's graph it then. Cut to the chase.
So I'd say you just throw it into honestly, because if all you're doing is plugging in points, then you're just plugging in, 2 and 4 in essence. So like you could do y equals absolute value of 3x, and you could put 0, which would be 0, 0. You could put 1 in, which would be 1 and 3.
Oh.
You put 2 in, which would be 2 and 6. And then I think you could probably do all the negatives for that one as well. And then for this one, you get x squared plus 2, so you could put 0 in for that, and you get 0, 2.
-2.
Put 1 in there, which would be 1 and 3. So 1 and 3 match up. Put 2 and 6 match up, and then it's probably going to be the opposite as well. So I think this one's a parabola.
A parabola.
So I got, for the ones that match, I've got 1 and 3, -1 and 3, 2 and 6, and -2 and 6.
Just like I have?
I don't know. I wasn't looking at the Hangouts. Sorry.
You're good. It's chill. It's chill.
I was looking at my thing, so. And then for the next ones, these are fractions.
How did you guys get the -1, 3, like the ones?
You what?
How did you guys get the 1, like the -1, 3, 1, 3? How did you guys get those ones?
Because what you do is you put something in for x, so that automatically becomes your x value. So we put 1 in for x, which then you have 1 times 3. And then that makes y equal 3. So your x value is 1 because you put 1 in for x, and then that makes your y value whatever that multiplies out to.
Okay.
Does that make sense?
Yeah. And then...
Oh, this is a cute little graph. And then, yeah, it's the same thing.
Then for these, I wonder if we could take the square root of both sides. I wonder if that would make it easier. Probably not.
Does that work?
And that's just, Chris, you got that just from graphing it?
Yeah. So we know it's correct. At least. Dang, I don't know why. I'll let you tell me how to do these, but it's been so long ago. Did you have you guys check the schedule recently?
No, I never really look at the schedule. I just kind of go with it.
I know we have one more exam and then the final, so we still have 2 tests in this class. Why? Did you check the schedule?
Yeah.
What's up?
So this week we don't have anything, but next week on Thursday we have the exam as usual, but then Wednesday is the final. And that's it. Just an odd way to.
So next week is the exam, and then the Wednesday after that is the final.
Yep.
Is that when it's due?
No, it's due the 17th.
Wow, it's due after classes end.
Yeah.
That's messed up.
That's how it goes, unfortunately.
Yeah.
Oh gosh. Screw it.
Is that +1?
What?
Is that +1? The y equals 3.
Yeah, it's +1.
Okay.
Let me check to make sure that's correct. Yep. That's the intersection.
0.25, 1.372.
Mm-hmm. 732. Okay. Guess we go to this hard one now. The following problem is a bit more difficult because it involves fractions with the variable in the denominator. The problem has been started for you. Discuss the method being used and why is it a good method to use, then finish the problem. So we had this ugly looking system here. So it says begin by multiplying the first equation by -2. Oh.
It still doesn't make any sense to me. Like, why would you want them to be negative?
Well, you want it to become positive.
Right, so why don't you multiply it by 2?
Say what?
So they multiplied the first equation by -2, right?
Yeah.
But why did they choose -2? I would have just chosen +2.
Oh, because it's already. Oh, I don't know. I don't know.
Is that because they wanted their x's to cancel out?
Yeah, that's why. That's the issue. They want the x's to cancel out. So then you get that nice equation at the end, and then you can substitute back in.
Oh, I see what they did now.
Yeah. So you have that nice equation, and so what you want to do is apply a little bit of.
You just multiply -5 by both sides. Is that right?
Yes.
So you'd have 5/3 the answer. Why 5/3?
5/3, yeah. So y will equal 5/3.
No. That's not right. You would divide -5 by both sides because it's not. No. Okay.
Say what?
Yeah, does that make sense? Because it's not y over -5. In that case, it would be you would multiply 5 by both sides.
Why did they multiply it by a -2 instead of just a regular 2?
Because they wanted to
go over that.
Yeah, we talked about that a little bit. They wanted to cancel out the x's. So if you multiply by -2, you get -4x and 4x.
Oh, I see. In order to make a common denominator.
Yeah.
But I thought these were two separate equations.
No, because you
So
have
did they just
this.
make them equal together? Adding the equations together because they have a common denominator. Okay, so they just set it equal to it and then added everything?
Yeah.
Yes.
Okay.
And my question
So
is,
now
why
we just
can't you?
gotta just multiply that by 5, right? Multiply that by -5?
You can't multiply. You have to divide it out.
What do you mean? What do you mean
You
by
have to
that?
divide the -5 out? Why would you have to divide it out?
Because it's in the numerator. If it were in the denominator, then you'd multiply.
Oh, yeah, you're right. I remember now.
You want to divide -1. Oh, wait. Hold it. So we want to cross multiply to get -5 times 3 equals to -1 times y, cross multiplication. We get -15 is equal to -y. And if you divide both sides by -1, you get y equals to 15. Yay. So now we can substitute that back into the original equation. We have 2 divided by x plus 3/15 equals to 1/2. See, this is the method I was talking about before that my algebra teacher told me about, but I couldn't remember for some reason. Oh, yeah.
What?
I was trying to do something that was rather pointless. Okay, so we want to subtract 3/15 from 1/2.
You'd have to make it into a common denominator, right?
Yes.
30. So it'd be 6 over 30 minus, is it 1/2 minus 3/15 or 3/15 minus 1/2?
1/2 minus 3/15.
So it would be 15 over 30 minus 6 over 30, which gives you 9 over 30. Divide that by 3. You'd have
3/10
3 over 10, yeah.
equals 2 divided by x. And then we have that times 2, which is...
No, it wouldn't be times 2. You'd have to divide it by 2 again.
Don't!
But an easier way to do it is you work from the other side. So you multiply both sides by 10.
So that'd be 3 equals 20 divided by x.
Yeah, and then just multiply both sides by x.
What do you mean? Do you mean multiply both sides by 20?
No, by x. So then you'd have 3x equals 20.
X equals to 20. And then 20/3 would be your answer.
Yeah.
X is equal to 20/3. 20/3.
I like that M there. It made it look more scientific.
That makes sense. I guess we could check the dealio.
Oh yeah, she has a cheat sheet, doesn't it?
Yep, and yep.
We got him right?
Yep.
Nailed it.
Did we get the bottom one right?
Oh, what a beautiful morning.
Okay, I guess we could discuss, though, since we're here, and it's only, I don't know, what time did we start?
9.
Yeah, so it's only 9:25. We've only been at this 25 minutes, and it's supposed to last an hour. So I presume we could at least discuss how to get the problems for number 1 without using a graphing calculator.
Well, I already went over that. I'd just throw in numbers.
I guess, yeah.
It's the best way for me to do it anyway.
Okay. Anything else you want to talk about?
How would you get like the last, not the one in gray, but like the third one down without using a graphing calculator?
Same thing, because it's set for y, so you just plug in. So what the homework said is always use like multiples of 2. That way it makes it easier, and you don't get any fractions. And so you could do 0 first, which would both make the first y 0. So you have 0, 0, right?
Mm-hmm.
Oh, no, I guess not. Why would that be not? Is that the only point?
Yeah.
That's weird. I have no idea then.
Let's see. Well, you know they both equal y, so they both equal each other. So I think you could go from there.
Set them equal to each other and then
solve it. And since we know about natural logs,
I don't want to remember them, but yeah.
2x, you would say it was 2x plus 1 ln of 3 will equal to negative x ln of 9. And so we can drop the ln, natural log, plus 1. It would be times 3, right?
I can't remember. Well, this does say to use the 3 different methods, so I wonder if there's a method to solve each one of these. I think the first, you use one method per equation. Does that make sense?
Yes. Oh, Solved by substitution, solved by addition, solved by elimination.
Yeah.
None of them is solved by graphing calculator. That's not even.
That'd be too easy.
That's what I like. What I need.
Oh, gotcha. I guess I'll do the first one with substitution. We have to find out what x is. So
X squared.
what?
So you just substitute absolute value 3x for x in the second one.
Or the other way around. So minus 2. So x would be the x. Okay. Let me do this. Minus 2 equals x squared. And we have the radical option v. Theta 2. That is what x equals. And so then you take
back in.
You take that. This is substitution. So you have your little handy dandy. The heck? You have 3 times root 2. Negative 2.
Where's the absolute value on the calculator?
What calculator do you have?
The graph calculator.
Should be there somewhere.
I don't know how to use half the things on this.
It's always good.
Okay, so then that's substitution, elimination, and addition we have. Addition down here.
Oh. Elimination. Found it.
Let's see.
So you line them up.
Yeah.
By, where is it? Right there. So, and you would add them together. So you'd have, I don't know. Let me write this out real quick. So you have to line them up. Kind of like that. And then you add it down.
You add downwards?
Yeah. Like it's complicated.
Elimination won't work for this. Sweetheart did elimination. That's what that is essentially. Yeah, that's what it is. Okay. So what were you saying again?
What?
What were you saying again?
So you basically by the addition method, you like line them up and then you add them down.
Yeah. Oh, hold it.
I don't know. It's probably backwards for you though.
19. Wait a minute.
Is that right? X plus x over 18 is 19 over 18x.
You can take it down. I took a screenshot.
Oh, you took a screenshot.
Yeah, that way I can work off the screenshot. That way you're not holding it annoyingly. Yeah. Yes. That looks good to me. Anybody have any qualms?
Nope. Just qualming it up. Just kidding.
I'm actually, the reason why I'm at the church and why there's a library in the background is because there's this kid in my ward. We grew up together, and my mom teaches seminary, so I help her with seminary anyway. But today he had to take his test kind of like we do because I think he's in calculus anyway. So he's taking it online at BYU Idaho like we are too, but his teacher makes him get a proctor for it. So he has to find somebody to sit there with him while he takes the test, and it has to be in a location that's not the proctor's house or the student's house.
Oh, so you're the proctor?
I'm not the proctor. My mom is.
Oh.
So this is after seminary. I have to find something to do. So
if I had to do that, I don't know what would be going on because I take hours on some of these exams.
Same. And I have like work too, so sometimes I'm done with the test at midnight. So I'm like, that would suck for the proctor.
Yeah.
Hey, proctor, can you come back later?
For real. Okay. Now what we got to do. What do we got to do?
It's hard because usually you use the addition system. Like the addition system is also known as the elimination system.
Yeah, it's the same thing.
Yeah, and usually you're able to cancel out one of them. Like that's the whole point, is so that you're able to cancel out.
Yeah, for real. Oh, you know what we'd have to do?
What?
We'd have to divide the top equation by -32, because that would get rid of the y. Does that make sense? So that would be x
squared over 18 times 32
squared over divided by.
That would just be 32x squared over 18, wouldn't it?
Wait a minute.
-32x squared over 18.
Let me just write it out just to make sure that I got it right,
Okay.
So yeah, now I'm stuck in a church library doing a Google Hangout. Awesome. Okay. So what is 25 times -32?
Wait, what? Why are you multiplying the top equation by -32?
So that this y squared. Oh, dividing me. I mean, not.
You only need to do one of the equations, don't you?
Yeah. Let me show you. Okay. Hold it. Yeah. Let me do it in a different color so it makes more sense.
Okay.
Okay, that's the original problem. So what I want to do is divide every bit of this equation by -32, so that when I come down here, and this line here is just a repeat of this line down here, or I should say this is a repeat of that. So I can cancel out this y, because this is a y divided by -32. This is a negative y squared divided by 32, and this one. So those will go away, and you can add.
Well, all you got to do in that top one is multiply it by 32 over 32 to cancel it out, right? And then multiply the right side by 32, and then you take the square root, and that'll get you x plus y equals the square root of whatever that number would be.
Wait, what?
That's what I would do. So
What
we
were
have
we
x
saying?
squared over negative 32 plus y squared over negative 32.
Yeah.
So multiply the whole thing by a negative 32, and then you add negative 7 by negative 32, and that'll get rid of your fractions.
That works. That works.
And then just take the square root of the whole thing if you want.
Oops. Let's not touch the last line, second line until we're done with the first line. Sound good?
Yeah.
Wait a minute. You're supposed to have them.
What?
You're supposed to have those fractions.
Well, why? Why can't you just get rid of them? I'd just get rid of them to make it easier.
The reason why we have those fractions is because we need to cancel out these fractions.
You can only cancel out one of the fractions with it. So
That's the point. How do I explain this? How do I explain this? How to explain?
wait, so you divided the top equation by negative 32.
Yes, that's what I'm. Yeah.
How did 25 divided by negative 32? How is that 7?
Did I do that wrong?
I don't know. I just feel like 25 divided by 32 isn't 7. Let me see. 25. It's negative 0.7.
Oh.
0.78. But I'd still leave it in the fraction form for now because
0.78. Yeah. Okay. So we have here that would be negative x squared divided by negative 32 equals negative 7 divided by negative 32 equals not 7 equals 25 divided by 25 divided by negative 32. There we go. There we go. There we go. Yeah. So then you can add those straight down from this one.
so you would get negative x squared over 14 is equal to 7.
Oh yeah. Negative negative x squared over 14 is equal to what did you say?
7.
7?
Yeah, I think so. Or 7 over 32 would be. I'm sorry, 7 over 32.
I was gonna say, isn't the answer I got wrong? And then you can multiply that by 14. Squared equals
Negative 98 over 32 is equal to x squared.
98 over 32.
You can multiply both sides by 32.
That works too. So that'd be negative 32x squared equals 98. No, I think that would work.
No, you would want to leave it back at the 98
Yeah.
by 32 because you'd need to
You can
go ahead.
get rid of that one, and I was going to say multiply both sides by negative 1 to get x positive.
Yeah.
And then x would equal the root Negative 98 divided by 32. X equals, stop doing that.
I think we're making this way too hard. If you ask me.
You think we are, or do you think the classes?
No, I just think we're making this one way too hard.
I mean, this is how. What would you have done?
I mean, it looks pretty simple up at the top, and so I would have, because 18 is a root of 32, so I would have just somehow made, I don't know, I would have multiplied it by 2 over 2. No, 18 times 2 is what, 36? Is that right? So it's not quite there then. Oh, no, I just think we're making it too hard. I don't know what we'd do differently, but.
I mean, you could plug and chug if you want. That's fine, Nothing wrong with that. I was just thinking.
Well, I'm just saying, even once we get this down to X, it's not going to give us the Y or anything because you guys got rid of the Y. So you're not going to find any X, Y values.
The whole purpose of the addition method is to get rid of one of the two values, or the Y value, or the X value.
Okay.
So X squared. Darn it. Oh, no, wait. Let me try that again. I think I may have the solution.
Dost thou?
7/4.
Yeah, this is just a super complicated version, or problem to have as your practice one.
Sure. Sorry to make this more complicated than it has to be. Oh, that's what. 25 and this is unnecessarily long, I know. Sorry.
How did you get that as the square root of 98 divided by 32?
Oh, I took the square root of 98 divided by 32 and threw a negative out front. Because it's negative right there. And the negative x squared.
I know. I know how you got the negative, but how did you get that the square root of 98 divided by 32 is 7 divided by 4?
Is that not what it is?
I don't know. I was just asking how you got it.
With a calculator.
So would you take the square root of 98 and the square root of 32 and keep it in the fraction form? Is that how you would do that, or?
Yeah. I honestly do agree, though, that this is making it really, really complicated. But what was it? That's wrong. That should be a plus. Dang it. Yeah, honestly. 4.68 negative.
Oh, yeah, you were right. My bad.
Okay, it's good. It's all good. Should you? Yeah. So that's what I got doing that. But I think that's one way of doing it, but I think there's a better way of doing it. Anyway.
Yeah, because that way it didn't give us the answer at all.
Yeah. So I think there must have been a better way to do it besides graphing. Anyway. Y'all want to talk about something else, or we're good?
I think we're good.
Yeah, I'm good. I'm sure the homework will show us how to do that problem a little easier, in my opinion.
When I did the homework, it said like 23 parts. So I don't know about that.
Yeah, okay then.
Let's hope. Do your best.
Yep. Yep. Do you? Okay. Anyway, so I guess I'll stop the broadcast now.
All right. Well, I gotta go take a shower. I got a Skype interview here in a little while.
Sweet.
Good
luck.
All right. See you guys.
See ya.
Peace.